By now you have a good idea of what heat exchangers are and how they work. And you know some of the kinds of things that can go wrong with heat exchangers. In this unit, we're going to find out what to do to cure these problems. We'll also take a look at what's done to keep heat exchangers in the plant working efficiently. We'll be seeing routine maintenance, typical repair jobs, and online temporary fixes. What we're going to be doing in this segment is give an overview of the subject so you'll have a broad picture of what your job on heat exchangers is going to be. We'll also look into a couple of very simple procedures in more detail before going on to a close look at major tasks. Now, when a heat exchanger is out of service for routine scheduled maintenance, the first thing needed is a thorough cleaning. With surface heat exchangers, condensers, and other shell and tube units, this usually means cleaning out the water boxes or headers and clearing the tubes of any blockage. Cleaning and inspection is also done with direct contact heat exchangers. With direct contact heat exchangers, you're usually looking for corrosion and scale and some of the problems they'll cause. This might be blockage of inlet nozzles, or loose scale might get into clean feed water as it leaves the heat exchanger. Maintenance on direct contact heaters is usually nothing but rewelding or replacing trays and tray supports. Since this is about all you'll ever need to worry about with direct contact heat exchangers, we'll limit our discussion in this unit to maintenance of surface heat exchangers. Cleaning out condensers often involves scraping tube sheets and raking accumulated crud out of water boxes. Headers and large shell and tube units are usually cleaner. In smaller units, it's just a matter of disassembling them for cleaning. Your cleaning methods will depend on what's going through the heat exchanger and the kinds of impurities in the fluids. Cleaning the inside of tubes can be done several ways. On bigger units, if the buildup is moderate and easy to remove, such as slime from algae and other water growth, a stream of water under high pressure will do the trick. You use a water gun, which is just held in the end of each tube. Pulling the trigger shoots water through the tube. Now, sometimes compressed air is mixed with the water to churn the muck and sludge off the walls of the tubes. Now, if deposits are really hard to remove, the same gun is used to shoot the tubes with rubber plugs, wire brushes, or metal scrapers, sometimes called bullets. The one you choose depends on what you're trying to get out, and that depends on what's going through the heat exchanger. Another way of cleaning tubes is rodding. It's the elbow grease version of shooting tubes and is practical on small heat exchangers like a small oil cooler. And there are also devices like plumber's snakes used to clean drains and sewers. They remove the toughest stuff with a rotating scraper on a flexible cable. In large heat exchangers, tube bundles can be pulled out so the outside of tubes can be cleaned. Corrosion, scale, and deposits can be brushed off with wire brushes. Once the heat exchanger is cleaned out, a thorough and careful inspection is in order to find any leaks that exist. While the system was running, there may have been no evidence of leakage problems. Regardless, it's really important to make your inspection as thorough as possible. The more careful you make your inspection, the less likely it is that a problem will crop up before the next scheduled maintenance. A number of things go into this detailed inspection. To check for leaks in a surface heat exchanger, you may use a dye check or you may perform a vacuum test. Now, these might be done while the component is in service, or they might be performed while the unit's down after it's been cleaned. After cleaning, a visual inspection is done for evidence of corrosion, cracking, or to look for any more blockage. While some heat exchangers are in service, a telltale dye can be added to the water going into them to look for any leaks. This is usually a fluorescent dye that glows when it's exposed to black light, a source of ultraviolet light. Any leakage will show up where the dye comes through. On condensers and other heat exchangers which are run under a vacuum check can be used to look for leaks. It involves placing sheets of thin plastic wrap on the tube sheets to cover both ends of the tubes. This is done while a vacuum is drawn on the shell of the component. Now, the plastic wrap is just like the stuff that you use in your kitchen, and it sticks to the tube sheets as well as to itself. Now, if there's a leak in a tube, the plastic wrap will be sucked into that tube. That's a dead giveaway. After a condenser or shell and tube heat exchanger is clean and a good, thorough inspection's been made, any leaks that have been found need to be taken care of. Now, generally, you plug a leaking tube at each end to keep fluid from going through. Normally, you don't try to stop the leak itself. Later on, we'll be seeing in detail how plugging is done. Sometimes you may find a leak around where a tube goes through the tube sheet. You might have to plug the tube, or you may be able to weld the end of the tube to the tube sheet. It's possible you may have to do both. Tube replacement is often a job that's farmed out. It may be farmed out to a refitter or back to the manufacturer of the unit. Sometimes, though, you may do such a job in-house. Tube replacement is almost always done in wholesale lots, when so many tubes have been plugged that the efficiency of the heat exchanger is affected. Tubes are usually set into tube sheets in one of two ways. One method is by rolling, which is a way of expanding the ends of the tubes into corrugated openings in the tube sheet. The other method is to weld the tubes into the tube sheet openings. Whichever way the tubes are set into the tube sheet, any that have to be replaced must be cut away very carefully. After removing the old tube, the new tube is set into place and fixed to the tube sheet the same way as the original tube. We'll be studying these things in more detail further on. We'll be going into inspection, cleaning, and repair jobs on both large and small heat exchangers. And we'll take a look at some of the equipment you'll be using on the job to see how it's done. Before we go on, let me mention the importance of sacrificial anodes. They aren't used in all heat exchangers, but attention has to be paid to them where they are used. There really isn't much you can say about sacrificial anodes, except that they're a little bit heavy, and the details of their maintenance are so simple that we won't spend a lot of time on the subject. We've already talked about them and discussed the way they work. They're called sacrificial because they are eaten away by corrosion rather than the metals of the heat exchanger. When they're worn down so far, they have to be replaced. Just when is usually a matter of judgment. But one rule of thumb is to replace them when they're more than 50% eaten away, or when they are in danger of coming loose from their mountings. Replacement is a straightforward job of just bolting a new one in the place of the old one, and you're done. After all the rest of your maintenance tasks are completed, it's time to clean up tools and equipment. When you've made sure that nothing's been overlooked, the unit can be closed up. It might be tested before it's put back into service. This might include flow testing, pressure or vacuum testing, leak tests, and so forth. It has to pass any tests that are performed before the component is ready to go back online. Routine maintenance tasks are usually pretty simple, about as simple as heat exchangers themselves. Still, each job has to be done with care and thoroughly completed. Then you can expect everything to work just fine when the system's put back into service. Now, before we go on further, pause to study the first section of your text and answer the questions. Get your instructor to clear up any questions you may have. When we come back, we're going to see what any big heat exchanger job begins with.